Hello everyone, this is our second video for SPSS. Now we are going to look at the descriptives. Descriptives are a little different from the frequency analysis. We go ahead with the descriptive analysis when we have variables that are measured on scale, not nominal or ordinal. So we'll go ahead with the analysis, analyze descriptive statistics, and again descriptives. So this time I'm going to select the two scale variables and I'll leave out the nominal and ordinal variables. So here we have these variables, and in the options I'm going to select the mean, standard deviation, minimum, maximum, kurtosis, and skewness. All right, so that's all what we need right now, and we'll click OK. Okay. You can see over here we have gotten these descriptive statistics. This is the frequency table that we generated last time, and right underneath we have descriptives over here. Now it's a very interesting analysis that we have gotten here. Now age, if you look at the variable age, it has 200 observations. The minimum age that we have received, the minimum statistic, is 30. The maximum is 78. The mean age of this sample is 55. And standard deviation of the age is 10. That's given over here. And then we have the skewness and kurtosis. Now, as a rule of thumb, a general rule, if your variable has skewness and kurtosis within the range of -1 and 1, -1 and +1, your value lies somewhere between that, it means that your data is acceptably closer to a normal data. But if it is beyond this value, like if it is something like -1.2 or 1.3 or 1.1 or something like that, that means that this data is not normal. It's a non-normal data. Now another way where you can analyze the kurtosis and skewness value is looking at the standard deviation. Now multiply this value of standard deviation over here with 3. If I multiply 0.172 by 3, roughly speaking, it would be 0.3 something, 0.31. All right. The value that we have in the statistic should be lesser than that. So absolute value 0.31 is bigger, and the statistic absolute value 0.106, it's smaller. So it means that we are lying within the safe range. But it's not the same case for the skewness related to our time to effect. 3 multiplied by the standard error is still the same, that is 0.31, but our skewness statistic is a bit higher than that. So we can be a little skeptical about the skewness value related to time effect. But still, it's satisfying one of our criteria that it is less than 1, so we'll accept it. Now there's one more thing that we can do with our analyze function. I'll go again to analyze descriptive statistic, going again to descriptives, but this time what I'm going to do is that I will draw a histogram as well. I want to see the histogram. Where is it? It's not here. Is it in the style? No, not at all. All right, I'll look at the histogram somewhere else. I know we can generate it. Maybe here. Okay. If I click on the graph, I can go to the chart builder. Okay. And now I'll select these two variables that I want. I'll drag them over here. Okay. And I want a histogram. Choose from histogram. I want this histogram, and it should be something like this. Basic elements, This is what I want. I want X and Y. And do I want anything else? No, I don't want anything else. Group point, tiles, nothing. So I guess that's all what I need here. It's basically this that I want for my histogram. And I also want a normal curve to overlay this particular kind of statistic. Yes, display the normal curve. So I'm clicking on that. So whatever my values will be, there would be a normal curve drawn over this statistic. So here it's okay. I'll click on OK. Oops, it's not accepting OK over here. Okay, what do I want? I want the time of effect on the x-axis, and that's what it's giving me here, and OK. So this is my first histogram. Now you can see that our skewness and kurtosis, in terms of skewness, if you look at it, it was positive. It means that if you have a positive skewness, it means that the bulge of your data or majority of your data would be on the left hand side, and there would be a tail, kind of a tail on the right hand side. And this is what we can see in our data here as well, that we have a lot of data over here. And there is a kind of a tail on the right hand side, but still it is of a bit acceptable nature. So it's like passing that criteria of normality. Now I'm going to go to the graph again, and we are going to build another histogram, but this time it would be a histogram related to age, not the time of effect. The other criteria would still remain the same. And this is what my histogram looks like. Now it's pretty normal. You can see that we have two tails, one tail on this side and the other tail on this side. And the bulge of data is there right in the middle. So we can comfortably say that it's acceptably normal here. And that's how we can analyze the normality of our data. And that is the first analysis, statistical inference that we make on our variables, that whether our data is normal or not. If your skewness and kurtosis is between -1 and +1, we would say that yes, it is acceptable and it is kind of normal. If in case you do not have the normality, but your sample size is 200 or more, we will still accept it, because for normal or for a larger sample size, we assume that there is normality. We ignore the non-normality for the larger sample size. So the question is, do we still perform the normality test? Yes, we perform the normality test. We report it in our analysis in the results. But we mentioned that as well, that since the sample size is bigger, normality would be assumed for this data set. So that's all for now for the descriptives. We'll meet again in another video.